Picture this. It's December 31st, 2025. New Year's Eve should be a time for celebration, but instead, the emergency broadcast systems across the entire world are transmitting the same terrifying message. The object that we have been calling 3I-ATLAS has just released thousands of smaller, independent bodies that are not following the simple, predictable ballistic trajectories of a normal comet. They are maneuvering, they are coordinating, and they are spreading out throughout the inner solar system with a clear purpose that screams of an intelligence rather than a physics. The amateur astronomers are posting the videos that are showing the comet's surface that is peeling away like a shedding skin, which is revealing a crystalline geometric structure that is underneath that catches the sunlight and reflects it in the patterns that are too perfect to be natural. What if I told you that while we have been debating whether the 3I-ATLAS is just an unusually rich carbon dioxide comet, it has been systematically cataloging every single satellite in the Earth's orbit, every military installation, and every major population center, a building, a complete tactical picture of a human civilization? What if those beautiful green emissions that we have photographed are not just the excited molecules that are fluorescing in a sunlight, but are the exhaust from the scanning beams that have been dissecting our planet layer by layer? What if we are not witnessing the peaceful passage of an interstellar traveler, but the final reconnaissance phase of an invasion plan that has been centuries in the making? Tonight, we are venturing into the darkest corners of a cosmic possibility and exploring how an intelligence that is millions of years more advanced than a humanity might approach the delicate problem of a planetary acquisition. This is an exploration for a sleep, though I suspect that tonight's revelations might leave you checking your windows more than counting the sheep. Before we embark on this journey, smash that like button if you are prepared to see our solar system through the eyes of a potential predator. Subscribe for more deep dives into the scenarios that keep the NASA awake at 3 in the morning. And drop a comment that is telling me what is the strangest thing that you have ever seen in the night sky that made you to wonder if we are really alone out here. Let's start by examining how the perfect predator might announce itself not with the roars and the fanfare, but with the terrifying silence of a Trojan horse. Now imagine this. You are watching the evening news when every screen flickers, your phone buzzes, and then it goes silent. The GPS in your car simply stops working. Above you, something that the astronomers have been calling a comet begins to unfold like a metallic flower, its petals that are spanning thousands of the miles around our planet. This is not happening, not yet. But 2025 has given us a visitor from beyond our solar system, and some of them are asking the uncomfortable questions about its true nature. The 3I-ATLAS arrived in our cosmic neighborhood with all of the subtlety of a whispered secret. On January 29th, the ATLAS Survey Telescope spotted what appeared to be just another chunk of an interstellar ice and a rock, a glowing green, as it approached our sun. A standard comet behavior, the experts said. Nothing to see here. But what if they are wrong? The idea of a Trojan horse is deceptively simple. You present a gift, you make it to look harmless and even desirable. The target accepts it willingly. Then when their guard is down, you reveal your true purpose. In an ancient Troy, it was the wooden soldiers that were hidden inside a monument. In the digital age, it is a malicious code that is disguised as a harmless file. In a space well, that is where the things get interesting. Consider what would happen if our satellites simply stopped working, not dramatically and exploded, or visibly destroyed, but just quietly ceased their functions. The global positioning system that guides everything from your morning commute to the emergency services would become useless. A weather forecasting would revert to a 19th century guesswork. The financial markets, which rely on a precise timing that is synchronized by the satellites, would collapse into a chaos. And internet traffic that bounces through the orbital relays would slow to a crawl. A modern civilization hangs by the threads that we rarely think about, the threads that dangle 400 miles above our heads. Cut those threads and a life does not end, but it certainly gets much harder very quickly. The green glow that the 3I-ATLAS displayed as it passed through our solar system could mean an everything or a nothing. The comets often appear to be green when a solar radiation excites a diatomic carbon in their coma, the cloud of a gas and a dust that surrounds their solid nucleus. It is a basic chemistry as predictable as a sunrise. But in our speculative scenario, what if that green light served another purpose entirely? What if it was a signal? Picture the doorbell cameras across a suburbia that are capturing the same eerie emerald glow, the backyard astronomers that are posting the viral clips of something that should not be there, and a social media that is filling with the theories that are ranging from the plausible to the absurd. The glow came right before our internet went down. Someone posts and ignoring the fact that a correlation does not imply a causation. But in our thought experiment, let's say that it does. Let's say that that green light was a wake-up call, an activation signal for the devices that have been awaiting patiently in the Earth's vicinity, the devices that were so small or so cleverly disguised that we had mistook them for a space debris or a natural phenomena. The beauty of a truly effective Trojan horse lies not in its complexity, but in its patience. The original wooden horse did not attack immediately. It waited. It let the Trojans to celebrate their apparent victory, let them to drag it inside their walls, and let them to grow comfortable with its presence. Only when the city slept did the hidden soldiers emerge. In our scenario, the 3I-ATLAS is not the weapon, it is the key. As we follow this visitor's journey through our solar system, we are forced to confront an uncomfortable truth about our place in the cosmos. We are astronomically speaking incredibly isolated and remarkably defenseless. The nearest star is over 4 light-years away. Any civilization that is capable of an interstellar travel would possess a technology that is so advanced that our military might would seem as threatening as a child's water gun. This asymmetry of a power creates a peculiar situation. If an alien intelligence wanted to study us, to influence us, or even to eliminate us, they would not need to announce their presence with the massive ships or the dramatic displays of a force. They would simply need to be patient and clever. The 3I-ATLAS fits that profile perfectly. It approaches at exactly the right angle to maximize its time in our solar system. Its composition appears to be consistent with a comet A, providing a perfect camouflage. Its behavior follows the predictable laws of a physics A, never straying into the realm of the obviously artificial. If you wanted to design the perfect reconnaissance probe, you would probably make it to look exactly like the 3I-ATLAS. Of course, there is no evidence for any of this. No radio signals have been detected, no unusual gravitational anomalies have been measured, and no debris has been found that could not be explained by the natural processes. The scientific community remains convinced that the 3I-ATLAS is exactly what it appears to be, a chunk of an ancient ice and a rock from another star system, following the same physical laws that govern every other celestial body. But that is the point of a good Trojan horse, is not it. It is supposed to look innocent. As the 3I-ATLAS continues its journey past the Jupiter and toward the outer reaches of our solar system, carrying whatever secrets it might hold, we are left with a question that is both thrilling and terrifying. In a universe that is full of the older, more advanced civilizations, how would we know if we were being watched? The third visitor. We are no longer alone in receiving the cosmic guests. The 3I-ATLAS represents only the third confirmed interstellar object to visit our solar system in a recorded history. This rarity makes every encounter precious, like finding a message in a bottle that was washed up on an infinite shore. The term interstellar carries a weight that is easy to overlook. Unlike the asteroids or the comets that were born in our own solar system, these objects originate from the alien suns, A, possibly orbiting the alien worlds, A, carrying the chemical signatures and the physical properties from the star systems that we can barely imagine. They are quite literally the pieces of the other worlds that are coming to call. When the 3I-ATLAS was first spotted by the ATLAS survey on January 29, 2025, it immediately joined an exclusive club. The first member, the Oumuamua, caused a sensation in 2017 with its peculiar elongated shape and an unexplained acceleration. The second, the 2I Borisov, behaved more like a traditional comet, which was complete with a classic tail of a gas and a dust. Now we have our third visitor, and the patterns are beginning to emerge. What makes these encounters so scientifically valuable is their origin. Our own solar system's comets and asteroids were formed roughly 4.5 billion years ago from the same primordial disk that created the planets. They are the family members, sharing a genetic material, so to speak. The interstellar objects, however, are the strangers with the foreign passports, carrying the chemical fingerprints of the distant stellar nurseries. The 3I-ATLAS likely spent the millions of the years drifting through the emptiness that is between the stars, a cosmic wanderer that was experiencing the temperatures that were barely above an absolute zero. Its journey to our solar system began long before the humans walked upright, perhaps before the Earth had developed a complex life at all. The patience that was required for such a voyage is almost incomprehensible to our mayfly lifespans. The discovery of the interstellar objects has become possible only recently, thanks to the advanced sky surveys that scan the heavens, like the security cameras, and automatically flagging anything that moves against the background stars. The ATLAS system, which discovered our current visitor, consists of the 4 telescopes that photograph the entire visible sky every 2 days, searching for the asteroids that might threaten the Earth. It is a testament to a human ingenuity that we can spot a dark, relatively small object that is moving against the starfield while it is still millions of the miles away. But it also highlights our limitations. For every interstellar visitor that we detect, the dozens of them probably pass through our solar system unnoticed, too small or too distant for our instruments to catch. This brings us to an unsettling realization. We are essentially blind to most of what happens in our own cosmic neighborhood. If an advanced civilization wanted to send the probes to study our solar system, they would have the numerous opportunities to do so without a detection. The question is not whether it is possible, but whether it is already happening. The 3I-ATLAS exhibits a classic comet behavior as it approaches the sun. A solar radiation heats its surface, causing the subsurface ices to sublimate directly into a gas, creating the characteristic fuzzy appearance that initially led the astronomers to classify it as a comet. This outgassing also creates a gentle rocket effect, pushing the object slightly off its gravitational trajectory in a perfectly predictable way. But here is where our speculative scenario becomes interesting. Any sufficiently advanced probe could easily mimic this behavior. The controlled gas emissions could provide both a camouflage and a propulsion, and allowing for the minor course corrections, while maintaining the appearance of a natural outgassing. The technology that was required would be well within the capabilities of any civilization that was advanced enough to launch the interstellar missions. The green color that the 3I-ATLAS displays is particularly intriguing. While the scientists explain it as an excited diatomic carbon, a common component of the comet comas, the specific shade and an intensity could theoretically encode an information. In our thought experiment, imagine if that green glow pulsed in the subtle patterns too complex to be natural, but too faint to be immediately obvious to our instruments. What would such a signal contain? Perhaps it is a beacon that was designed to be detected by a technology that was more advanced than our current capabilities. Perhaps it is a countdown that is marking a time until some predetermined event. Or perhaps it is simply a greeting, a cosmic hello, from the intelligences that are so far beyond us that we are not yet ready to understand the message. The timing of the 3I-ATLAS's arrival adds another layer to our speculation. It appeared just as humanity is developing a serious space-based infrastructure and beginning to contemplate the interstellar missions of our own. If you were monitoring a developing civilization, this would be the perfect time to conduct a closer inspection. We are advanced enough to be interesting, but not yet advanced enough to pose a threat. Consider the broader context. In the recent years, the U.S. government has acknowledged the existence of the unidentified aerial phenomena. The scientists have detected the potentially artificial radio signals from space, and our own attempts to find an extraterrestrial intelligence have become more sophisticated and wide-reaching. The universe seems to be knocking on our door with an increasing frequency. The 3I-ATLAS fits perfectly into this timeline of an escalating strangeness. It is natural enough to avoid causing a panic, but unusual enough to capture an attention. It arrives at precisely the moment when we are most likely to notice and to study such objects. If you were planning a reconnaissance mission, you could not ask for a better timing. But a timing alone does not make a case for an artificial origin. The universe is vast and ancient, which is full of the coincidences that seem to be meaningful only in a retrospect. For every pattern that we think that we see, there are the countless others that exist only in our imagination. The human brain is designed to find the connections even where none of them exist. Still, the fact remains that the 3I-ATLAS is only our third confirmed interstellar visitor, which is making it a statistical anomaly that is worthy of a careful observation. As it continues its journey through our solar system, every measurement that we take adds to our understanding of what lies beyond our cosmic shores. What secrets might it carry from its origin system? What stories could it tell of the space that is between the stars? And perhaps most importantly, what might it reveal about who or what sent it our way? The green fire in the sky. The color green in a space holds a special place in both a science and a speculation. When the 3I-ATLAS began glowing with that characteristic emerald hue, the astronomers had a ready explanation: an excited diatomic carbon molecule in the comet's coma, a perfectly natural phenomenon that was observed in the countless comets throughout a history. But in our world of a what if, that green light takes on the more sinister implications. A color has always been humanity's first clue to an understanding the unknown. The traffic lights use a green to mean go. The emergency exits glow a green to show the way out. In nature, a green often signals a life, a growth, and a safety. But a green fire in the sky, that is something that is altogether different. It suggests a chemistry that does not quite fit an energy that is being released in the ways that make you to look twice. The specific shade of a green that the 3I-ATLAS displayed during its approach to the Sun falls within a narrow spectroscopic range. When it is analyzed through the powerful telescopes, this light reveals its chemical signature as clearly as a fingerprint. The carbon atoms that are energized by a solar radiation emit the photons at the specific wavelengths. The process is so well understood that the astronomers use it to determine the composition of the objects that are millions of the miles away. Yet in our speculative framework, what if that green glow served a dual purpose? What if those carbon emissions were not just the natural byproduct of a solar heating, but also provided a cover for something that was more deliberate? Imagine the microscopic devices that were using the comet's own outgassing as a means of a distribution, riding those streams of a gas and a dust like the seeds on the wind. The timing of the 3I-ATLAS's brightest green phase coincides perfectly with its closest approach to the Sun and exactly when a natural physics would predict a maximum outgassing activity. But it also represents the moment when any hidden technology would have an access to a maximum energy from our star. The solar panels are, after all, one of our most reliable forms of a space-based power generation. An advanced civilization would likely have perfected the similar techniques the eons ago. The amateur astronomers around the world captured the stunning images of the 3I-ATLAS during its green phase. Their backyard telescopes that were revealing the details that would have been impossible to observe just the decades ago. These citizen scientists, who were armed with the digital cameras and the computer-controlled mounts, have become an unofficial early warning system for the unusual celestial phenomena. Their collective observations create a distributed surveillance network that no government or an institution could match. In our thought experiment, imagine if some of these amateur observers began reporting the subtle anomalies, a flash of a light that lasted just a few seconds longer than a thermal modeling would predict. A slight wobble in the object's rotation that did not match the gravitational influences, and the small discrepancies that could be explained away individually but that form a pattern when they are viewed collectively. The beauty of using a comet as a camouflage lies in the inherent variability of these objects. The real comets are the temperamental, unpredictable things. Their brightness can fluctuate wildly as the different patches of a surface ice are exposed to a sunlight. Their rotation can change as an asymmetric outgassing creates an uneven thrust. Their chemical composition can vary from a region to a region, creating the different spectral signatures as the object tumbles through a space. This natural chaos provides a perfect cover for an artificial activity. Any unusual behavior can be explained as a typical comet's weirdness. Any unexpected signal can be dismissed as an instrumental error or a misidentification. The noise of a natural variation drowns out the signal of a potential intelligence, but the signals have a way of accumulating. In our speculative scenario, the radio telescopes around the world begin detecting the faint transmissions from the direction of the 3I-ATLAS. The signals are weak, intermittent, and easily dismissed as an interference from the Earth-based sources. Individually, they mean a nothing. But when they are plotted over a time, they reveal a pattern that is hard to ignore. The green glow serves another purpose in our fictional narrative. It is visible to the naked eye under the dark skies, which is making the 3I-ATLAS one of the few interstellar objects that the amateur observers can spot without a sophisticated equipment. This accessibility democratizes the discovery process, turning the millions of the potential witnesses into the inadvertent participants in whatever might be an unfolding. The social media platforms buzz with the images and the videos of the green visitor. Most of the posts treat it as a novelty, a cosmic curiosity to share with the friends. But embedded in this flood of the casual observations are the data points that the professional astronomers might miss the exact timing of the brightness variations, the precise color shifts as the object moves through the different regions of a space, and the subtle changes in an appearance that only become obvious when the thousands of the independent observations are compared. The psychological impact of the green glow cannot be understated. Throughout a human history, the unusual lights in the sky have been interpreted as the omens, whether they are a divine or a demonic. The aurora displays have inspired both a worship and a terror. The comets have been seen as the harbingers of a war, a plague, and the fall of the empires. The 3I-ATLAS, with its alien origin and its eerie green luminescence, taps into these primal fears and the fascinations. In our fictional scenario, the conspiracy theories begin to emerge almost immediately. The online forums fill with the increasingly elaborate explanations for the object's behavior. Some of them claim that it is a scanning device that is probing the Earth's electromagnetic environment. Others suggest that it is a beacon that is calling to the other interstellar visitors. A few of them insist that it is a weapon system that is powering up for some unimaginable attack. The truth, as it always is, likely lies somewhere between the mundane and the extraordinary. The 3I-ATLAS is almost certainly a natural object that is following the natural laws. But in a universe where we know so little about what is possible, and almost certainly leaves a room for a doubt. And a doubt, as any good storyteller knows, is where the most interesting possibilities live. As the green fire fades and the 3I-ATLAS continues its journey toward the outer solar system, it leaves behind more questions than the answers. Was that emerald glow simply the death throes of an ancient ice that was meeting a starlight? Or was it something else entirely? A signal that was transmitted across the impossible distances, and that was finally reaching its intended destination. The first questions. When you encounter something that is truly unknown, the first question is not what is it, but what is it not? The 3I-ATLAS presents us with a classic identification challenge, a natural phenomenon or an artificial construct. The distinction matters more than you might think because it determines everything about how we should respond. The natural objects follow the predictable patterns. They obey the laws of a physics without a deviation or a surprise. When a chunk of an ice and a rock from another star system enters our cosmic neighborhood, it behaves exactly as an orbital mechanics suggests that it should. A gravity pulls it toward the massive objects, a solar radiation heats its surface, and a sublimating ice creates the gas jets that push it slightly off a course. These processes have been occurring for billions of years throughout the universe. But what if the 3I-ATLAS is wearing a mask? The art of a cosmic camouflage would be surprisingly straightforward for any civilization that was capable of an interstellar travel. You begin with a real comet's nucleus, something with the proper chemical composition and a structural integrity to survive the journey that is between the stars. Then you add your technology so seamlessly that it becomes indistinguishable from the natural object itself. Imagine the microscopic sensors that are embedded within the ice matrix, which are powered by the thermal differences and are designed to activate only when they are exposed to the specific radiation signature of a main sequence star like our Sun. Picture the communication devices that use the comet's own outgassing as a transmission medium and encoding data in the subtle variations of a gas density and a composition. And envision the propulsion systems that work by selectively heating the different regions of the surface, creating the precisely controlled jets that appear to be completely natural to an external observation. The engineering challenges would be immense, but not impossible for a sufficiently advanced civilization. The devices would need to survive the millions of the years in the cold emptiness of an interstellar space. They would need to remain functional through the temperature swings that would destroy most of the materials that we know. They would need to operate with a perfect reliability the first time that they are activated, with no possibility of a maintenance or a repair. But consider the payoff: a reconnaissance system that could study an alien world from within its own solar system, a completely and undetected, a gathering, a data on and everything from an atmospheric composition to a technological capability. The intelligence value would be enormous. What would such a system look for? Perhaps it would analyze the Earth's radio emissions, a mapping our communication networks, and a technological development. It might study our atmospheric chemistry, a looking for the signs of an industrial activity and an environmental change. It could monitor our space-based infrastructure, a cataloging our satellites, and an assessing our defensive capabilities. The most intriguingly, it could be a looking for the signs of the other artificial objects in our solar system. After all, if one civilization can send the covert probes to study the developing worlds, then the others probably can too. The 3I-ATLAS might be a conducting a census, a determining who else might be a watching the Earth and what their intentions might be. The timing of its arrival supports this speculation. 2025 finds a humanity at a crucial developmental threshold. We have the permanent space stations, the reusable rockets, and the ambitious plans for the lunar colonies and the Mars missions. We are also developing the increasingly sophisticated methods for detecting the potentially hazardous asteroids and the comets. Any alien intelligence would want to study us now before we become too advanced to monitor safely, but the natural explanations remain far more likely than the artificial ones. An interstellar space is vast and mostly empty, but it is not completely sterile. The objects get ejected from their home star systems by the gravitational interactions with the planets or the passing stars. They wander through the galaxy for the eons before a chance brings them close to another stellar system. The process is random but inevitable, which is driven by the same forces that sculpted the universe itself. The 3I-ATLAS displays all of the characteristics that we would expect from such a natural wanderer. Its chemical composition matches that of the comets in our own outer solar system. Its trajectory follows a hyperbolic path that clearly indicates an interstellar origin. Its behavior changes in precisely the ways that a thermal modeling predicts. Every measurement that we have taken confirms that it is exactly what it appears to be. Yet an appearance can be deceiving, especially when dealing with the intelligences that might be the millions or the billions of the years more advanced than ourselves. The technology gap that is between us and a truly advanced civilization would be so vast that their artifacts might seem like a magic to us. The Arthur C. Clarke's famous observation that any sufficiently advanced technology is indistinguishable from a magic applies with a particular force to the question of an alien visitation. Consider what a humanity might be capable of in just a few thousand years of a continued technological development. We are already experimenting with a nanotechnology, an artificial intelligence, and a genetic engineering. We are beginning to understand how to manipulate a matter at the molecular level and how to create the self-replicating systems. Given enough of a time, we might well develop the ability to create the probes that are virtually indistinguishable from the natural objects. If we can conceive of such possibilities, then what might a civilization with the millions of the years of an additional development time have achieved? Their technology might be so seamlessly integrated with the natural processes that the distinction between an artificial and a natural becomes meaningless. The search for the artificial signals from the 3I-ATLAS has so far yielded nothing unusual. The radio telescopes have detected no transmissions, the infrared observations have revealed no unexpected heat signatures, and a spectroscopic analysis has found no artificial materials. By every measure that we can apply, it appears to be a natural object that is following the natural laws. But an absence of an evidence is not an evidence of an absence, particularly when dealing with a technology that we do not understand. A truly advanced probe might communicate by using the methods that we have not discovered yet, or operate on the principles that we have not conceived. It might be so perfectly camouflaged that our instruments simply cannot distinguish it from the natural object that it is pretending to be. As the 3I-ATLAS continues its journey past the Jupiter and toward the outer reaches of our solar system, we are left with the fundamental question that defines our relationship with the cosmos. Are we alone? The answer to that question will ultimately depend not just on what we discover about this particular visitor, but on how we choose to interpret the evidence that we gather. In the meantime, we watch, and we wait, and we wonder. Because in a universe that is full of the possibilities, the most dangerous assumption might be that we already know what is normal. The original Trojan horse. The story begins with a 10-year war that seemed to be destined to last forever. Troy stood unconquered behind its massive walls while the Greek ships blackened the beaches that were below. The heroes fell, the gods intervened, and still the stalemate continued. Then an Odysseus, a master of cunning, proposed a solution that would echo through a history, a gift that was really a trap. The wooden horse that they had constructed was a masterpiece of a deception, a large enough to hide the dozens of the soldiers, a beautiful enough to seem like a worthy offering to the gods, and a clever enough to exploit the one weakness, that the walls could not defend against the human desire to believe what we want to believe. The Trojans wanted to believe that they had won. They wanted to believe that the Greeks had given up. The most of all, they wanted to believe that the magnificent horse was exactly what it appeared to be, a tribute to their victory. We know how the story ends. The gates were opened, the soldiers emerged, and a civilization fell in a single night. But the tale's endurance through the 28 centuries suggests that it represents something that is more than a historical military strategy. It has become our template for an understanding a deception itself, the blueprint for a recognizing when the apparent gifts might hide the darker intentions. In the digital age, we have updated the metaphor without changing its essential truth. The computer users receive the emails that appear to contain the harmless attachments, a cute cat video, a funny meme, and an important document. A click on it and a malicious code infiltrates your system, stealing a data or turning your computer into a part of a criminal network. The delivery method has evolved from a wood to an electron, but the psychology remains identical. The space-based Trojan horses would operate on an even grander scale. Instead of conquering a city or compromising a computer, they would target an entire world. The camouflage would need to be perfect, the payload would be carefully chosen, and the timing would be precisely calculated. The most importantly, the target species would need to invite the threat inside their defenses voluntarily. The 3I-ATLAS fits this profile with an uncomfortable precision. It approaches from an interstellar space and immediately capturing our attention and a scientific interest. Its behavior appears to be completely natural, triggering no defensive responses. We track it eagerly with our most powerful telescopes and effectively providing it with a detailed reconnaissance data about our observational capabilities. If it were an artificial construct, it could not ask for a warmer welcome. The original Trojan horse succeeded because it exploited the cultural expectations. The Greeks knew that the religious offerings were common in an ancient warfare, and that the beautiful objects held a special significance in a Troy's culture. A space-based Trojan would need a similar cultural intelligence and understanding how the target species thinks about the visitors from the stars. The humans have a complicated relationship with the unknown. We are simultaneously fascinated by a mystery and terrified by it. We want to discover an alien life, but fear what that discovery might mean for our place in the universe. We build the radio telescopes to listen for the extraterrestrial signals, while simultaneously worrying about what might hear us calling back. This psychological complexity creates the numerous opportunities for an exploitation. An artificial object that was disguised as a natural comet would navigate these contradictions perfectly. It would satisfy our curiosity without triggering our fears. It would seem to be an exotic enough to warrant a study, but familiar enough to feel safe. The most crucially, it would appear to be something that had happened to us, rather than something that was directed at us, preserving our illusion of a cosmic significance, while gathering the intelligence that was needed for whatever comes next. The patience that was required for such a strategy would be almost incomprehensible to the human planners. The military campaigns are measured in the months or the years, the corporate strategies in the decades at most. But a space-based Trojan horse might operate on the timescales of the centuries or the millennia. It could afford to wait for the perfect moment, the ideal opportunity, and the precise alignment of the circumstances that would guarantee a success. Consider what such a patient observer might have witnessed during its approach to our solar system, the gradual development of a human technology, from the radio waves to a space travel, the emergence of the global communication networks and a satellite infrastructure, and the growing awareness of our own vulnerability to the cosmic threats. An artificial intelligence that was monitoring these developments would know exactly when we had become advanced enough to be worth a studying, but not yet advanced enough to pose a threat. The beauty of the comet's disguise lies in its inherent temporary nature. The natural comets make a single pass through the inner solar system before heading back toward an interstellar space, a potentially never to return. This provides a perfect cover for a hit-and-run reconnaissance. The object appears, gathers its intelligence, and disappears before anyone can mount a thorough investigation. But what if a departure is not a part of the plan? What if the Trojan horse's analogy extends to the final act where the hidden contents emerge to accomplish their true mission? In the original story, the Greek soldiers did not remain hidden forever. They waited until the city slept, then they opened the horse's belly and poured out into the streets of Troy. The space-based equivalent might involve the deployment of the smaller probes, the microscopic devices that were riding the comet's tail as it passes close to the Earth. These secondary payloads could establish the permanent surveillance networks in our vicinity, which were powered by a solar radiation and were designed to operate for the decades or the centuries. We would never know that they were there, hidden among the millions of the pieces of a natural space debris that orbit our planet. Alternatively, the Trojan horse might serve a more direct purpose. As the 3I-ATLAS approaches its closest point to the Earth in a late 2025, it could release its true payload, not the soldiers, but something that is far more sophisticated. The self-replicating nanomachines, the biological agents that were designed to integrate with the terrestrial ecosystems or the communication devices that piggyback on our own satellite networks. The possibilities are limited only by the imagination and the capabilities of whoever sent it. Of course, this remains a pure speculation. The 3I-ATLAS shows no signs of an artificial origin, no evidence of a hidden purpose, and no indication that it is anything other than what it appears to be. But that is exactly what made the original Trojan horse so effective. No one had suspected the magnificent wooden tribute until it was far too late to matter. The question that we are left with is not whether the 3I-ATLAS is an artificial, but whether we would recognize it if it were. Our detection methods are designed to find the natural phenomena and the man-made objects that behave according to the human engineering principles. An artifact that was created by a civilization that was millions of years more advanced than ours might operate according to the principles that we have not discovered yet. As our interstellar visitor continues its journey through our solar system, we can only observe, analyze, and wonder, because in the end, the most successful Trojan horses are the ones that no one sees coming until the gates are already open and it is too late to close them again. The Oumuamua, the first suspect. October 19th, 2017 changed and everything, not a visibly, not a dramatically, but in the quiet way that the paradigms shift when no one is looking. That is when the astronomers spotted something that should not have been there. A dark, elongated object that was tumbling through our solar system on a trajectory that clearly marked it as an interstellar visitor. They named it the Oumuamua, a Hawaiian for a messenger from afar who is arriving first. The name proved to be prophetic in the ways that its creators could not have imagined, because this cosmic messenger brought the questions that still have not been answered, and the possibilities that still make the scientists uncomfortable. The Oumuamua was strange in the ways that the natural objects are not supposed to be. Its shape defied an easy categorization somewhere between 10 and 100 times longer than it was wide, like a cosmic cigar or an interstellar pancake. Its surface was unusually red and remarkably smooth, reflecting less a light than a charcoal. The most puzzling of all, it accelerated as it moved away from the sun, gaining a speed in a way that could not be explained by the gravitational forces alone. In the controlled language of the scientific papers, these observations were described as an unusual and an unexpected. In the less restrained corners of the internet, they were interpreted as an evidence of an artificial origin. The object's elongated shape resembled no known natural formation. Its acceleration suggested some form of a propulsion, and its trajectory brought it close enough to the Earth to be easily observed, almost as if it had been planned that way. The scientific community responded with an admirable caution and a considerable creativity. They proposed that the Oumuamua might be a fragment of a larger object that was broken apart by the gravitational forces during its journey through space. They suggested that it could be unusually flat like a cosmic pancake, which would explain both its shape and its acceleration patterns. They theorized about the exotic forms of an outgassing that might be invisible to our instruments, but still capable of providing a thrust. Each explanation required a stretching the boundaries of what we considered a normal, but a stretching those boundaries was preferable to an accepting the alternative that we had been visited by something that was artificial. The timing of the Oumuamua's discovery coincided with humanity's growing awareness of our cosmic vulnerability. The same year that it appeared, the NASA launched its Planetary Defense Coordination Office, which was tasked with tracking the potentially hazardous asteroids and the comets. The idea that the dangerous objects might be heading our way was a shifting from a science fiction to a government policy. But the Oumuamua was not dangerous in any conventional sense. It posed no threat of an impact, it carried no obvious weapons, and it displayed no hostile behavior. If anything, it seemed to be almost benign, a content to observe our solar system from a respectful distance before continuing on its way. This restraint was either an evidence of its natural origin or the most unsettling thing about it. The object's behavior during its close approach to the Sun followed the patterns that could be interpreted either as a natural or an artificial. It brightened and dimmed in the regular cycles, which were consistent with a tumbling object of an irregular shape, but those cycles were also consistent with a controlled rotation that was designed to maximize an exposure to a solar radiation for a power generation. The distinction between a natural and an artificial became uncomfortably blurred. The radio telescopes that were trained on the Oumuamua detected nothing unusual, no signals that would indicate an artificial origin. This absence of an evidence became an evidence of an absence for most of the astronomers, confirming that the object was a natural, despite its odd characteristics, but it could equally well indicate a sophisticated technology that was designed to operate covertly using the communication methods that we have not discovered, or an encryption that we cannot break. The brief window that was available for an observation made the definitive conclusions impossible. The Oumuamua was discovered only after it had already passed its closest approach to the Sun and was heading back toward an interstellar space. By the time that the scientists realized what they were looking at, the object was already too distant for a detailed study. Within the months, it had faded from view entirely, carrying its secrets back into the darkness that is between the stars. This limitation highlighted a crucial weakness in our cosmic surveillance capabilities. We are reasonably good at detecting the objects that threaten the Earth directly, but we are terrible at spotting the interstellar visitors until they are already leaving. By a design or a coincidence, the Oumuamua's trajectory maximized the time that was available for a reconnaissance, while minimizing the opportunity for a detailed examination. The cultural impact of the Oumuamua extended far beyond the scientific circles. It became the first interstellar object that the non-specialists knew by a name, the first visitor from beyond our solar system to capture a public imagination. A popular media seized on its mysterious properties, generating the countless articles about the alien artifacts and the interstellar probes. The scientific community pushed back against these interpretations, but the questions lingered. What bothered many of the observers was not just the Oumuamua's strange behavior, but its apparent uniqueness. If the interstellar objects were common, we should have been detecting them regularly once our survey capabilities had improved. Instead, we found one bizarre outlier that defied an easy explanation. The statistical improbability of this situation suggested either a remarkable coincidence or a careful planning. The discovery also revealed how unprepared we were for a genuine contact with something that was alien. Our protocols for dealing with the potentially hazardous asteroids were well developed, but our procedures for investigating the artificial objects were virtually non-existent. If the Oumuamua had been a probe, we would have had no established method for attempting a communication or determining its intentions. The object's departure from our solar system marked the end of a direct observation, but not the end of a speculation. The computer models continue to refine our understanding of its trajectory, tracing its possible origins, and predicting its future path. The calculation suggests that it may have originated from the direction of the star Vega, though its journey likely began the millions of the years ago when that star was in a different position. This temporal disconnect illustrates one of the most challenging aspects of an interstellar archaeology. Any civilization that was capable of launching the probes across such distances would be operating on the timescales that dwarf a human history. Their missions might span the geological ages, their objectives might transcend anything that we can currently comprehend. The Oumuamua established a template for how we might recognize the future interstellar visitors. Its discovery improved our survey techniques and sharpened our criteria for distinguishing between the natural and the potentially artificial objects, but it also demonstrated the limits of those techniques and the ambiguity that is inherent in interpreting data from the objects that we can barely see. As we continue to debate what the Oumuamua actually was, we are forced to confront a larger question about our place in the cosmos. If we are indeed being visited by the artificial objects, then what does that say about the intelligence that is behind them? Are they studying us and ignoring us, or preparing us for something that we cannot yet imagine? The answers may come from the next interstellar visitor or the one after that, because the Oumuamua taught us that we are no longer alone in receiving the guests from the stars, and each new arrival brings the possibility of finally understanding what they want. The Atlas versus the gods. The names have a power, especially when they echo through a mythology and into the realm of a science. The 3I-ATLAS carries the designation of a figure from an ancient Greek legend, the Titan, who was condemned to hold up the heavens for an eternity, bearing the weight of the entire sky upon his shoulders. It is a name that conjures the images of an immense strength, an eternal vigilance, and a cosmic responsibility. The prosaic truth is that the 3I-ATLAS gets its name from the Atlas Survey Telescope that discovered it, an acronym for the Asteroid Terrestrial Impact Last Alert System. The mythological connection is purely coincidental, a product of a bureaucratic naming convention rather than a cosmic destiny. But the coincidences have a way of feeling meaningful when they involve the visitors from the other star systems. Throughout history, the humans have found the patterns in a randomness and a meaning in a coincidence. We see the faces in the clouds, hear the voices in a wind, and discover the prophecies in the movement of the celestial objects. This tendency toward pareidolia, the perception of a significance in a meaningless data, has shaped our understanding of the universe since we first looked up at the night sky. The name Atlas resonates because it speaks to our deepest fears about a cosmic responsibility. In the original myth, an atlas was not just strong enough to hold up the sky, he was condemned to do so as a punishment for challenging the gods. The weight of the heavens became both his burden and his prison, a task that could never be completed but must never be abandoned. And applied to our interstellar visitor, the name suggests something that is equally weighty and eternal. Is the 3I-ATLAS carrying some cosmic burden across the galaxy? Is it shouldering the responsibilities that we cannot comprehend? Or is it like its mythological namesake, being punished for some transgression against the powers that are beyond our understanding? The psychology of a naming reveals how deeply a mythology penetrates our scientific thinking. When the astronomers discover the new objects, they often reach for the names that carry a cultural weight, even when those names come from the automated survey systems. The Oumuamua evokes the mysterious messengers from the distant shores. The Borisov honors a dedicated observer who had spent the years scanning the skies. And the Atlas suggests the Titans and the cosmic forces that are beyond a human comprehension. These associations are not accidental. They reflect our need to contextualize the unknown within the familiar frameworks to make the alien comprehensible by connecting it to the stories that we already understand. But they also reveal our biases and our expectations, the cultural lenses through which we interpret the objective phenomena. In our speculative scenario, the mythological resonance of the name becomes more than a coincidence. What if the 3I-ATLAS truly is a bearing some cosmic burden, a carrying out a mission that is so vast and so patient that it spans the space that is between the stars? What if its journey to our solar system represents not a random wandering, but a purposeful pilgrimage, the completion of a task that was assigned the eons ago by the intelligences that we have never imagined? The original Atlas was positioned at the western edge of the known world, holding up the sky where the Mediterranean met the infinite ocean. The 3I-ATLAS approaches from the direction of the constellation Lynx at the edge of our cosmic neighborhood, where the solar system meets the infinite void. The parallel positioning seems to be almost deliberately symbolic. The ancient maps often featured the elaborate cartouches that were warning that "here be dragons" at the edges of the explored territory. These warnings acknowledged both the limits of a knowledge and the possibilities that lay beyond those limits. The 3I-ATLAS comes from such a region, from the dragons that are beyond our cosmic maps, carrying whatever secrets exist in the spaces that are between the stars. The Titan Atlas was known for his intelligence as well as his strength. He was said to be the first astronomer, the inventor of a celestial navigation, and the one who had taught the humans to read the movements of the stars and the planets. If the 3I-ATLAS were indeed an artificial, which was created by the intelligences that were capable of an interstellar travel, it would represent a similar gift of a cosmic knowledge, a teacher that was arriving from the ultimate classroom of a deep space. But the names can also be deceptive, creating the expectations that a reality does not fulfill. The planet Venus was named for the goddess of a love and a beauty, despite it being a hellish world of a crushing pressure and a sulfuric acid cloud. The constellation Cancer, the crab, looks nothing like its namesake when it is viewed from the Earth. The names reflect a human psychology more than an objective truth. This psychological projection extends to our interpretation of the 3I-ATLAS's behavior and its characteristics. We see its green glow and think of the traffic lights, the exit signs, the alien energy weapons, or any of 100 cultural associations with that particular color. We note its interstellar origin and imagine the vast alien civilizations, the cosmic messengers, or the technological artifacts that are beyond our comprehension. The power of the mythological names lies in their ability to shape a narrative, to provide a framework for an understanding that goes beyond a mere observation and a measurement. When we call something an atlas, we are not just assigning a label, we are invoking an entire cosmology of the titans and the gods, a punishment and a responsibility, a strength and an eternal burden. In our thought experiment, the 3I-ATLAS becomes more than a chunk of an ice and a rock from another star system. It becomes a character in an unfolding drama, a player in a story that began long before the humans existed and may continue long after we are gone. The mythological framework gives it an agency and a purpose, transforming a passive observation into an active interpretation. The ancient Greeks understood that the names carried a weight that was beyond a mere identification. They believed that knowing something's true name gave you a power over it, which is why so many of the mythological figures went by the epithets and the titles rather than revealing their actual identities. If the 3I-ATLAS were indeed an artificial, if it carried some hidden purpose or an alien intelligence, then its true name might be something that we could not pronounce or even comprehend. The Atlas survey that discovered our visitor operates the 4 telescopes that are located in Hawaii and South Africa, scanning the entire visible sky every 2 days. Like their mythological namesake, these instruments bear the weight of a cosmic vigilance, a watching for the threats that could fall from the heavens without a warning. They are our modern sentinels, our technological atlas figures that are standing a guard at the edge of the known world. But a vigilance cuts both of the ways. The same systems that watch for the dangerous asteroids also detect the interstellar visitors, creating a surveillance network that any advanced civilization would need to account for when planning the reconnaissance missions. If the 3I-ATLAS were an artificial, its creators would have known about our detection capabilities and would have planned accordingly. The mythological Atlas was eventually freed from his burden by the hero Perseus, who had used the Medusa's head to turn the Titan into a stone, transforming him into the Atlas Mountains of North Africa. The story suggests that even the eternal punishments can eventually end, that the burdens that were carried across a cosmic time might finally be set down. As the 3I-ATLAS continues its journey through our solar system, we are left wondering what a burden it might be carrying, and whether that burden will eventually be set down here in our corner of the galaxy. The name resonates with the possibilities that stretch far beyond an astronomical nomenclature into the realm of a myth and a meaning, where the most important truths often hide. Whether that resonance represents a genuine significance or a simple coincidence remains to be seen. But in a universe where a meaning and a randomness often wear each other's faces, sometimes the most important question is not what something is, but what it means to call it by a particular name. The signals in the noise. Every astronomical observation is an exercise in a detective work separating the genuine phenomena from the instrumental artifacts, the cosmic events from a terrestrial interference, and the meaningful patterns from a random noise. With the 3I-ATLAS, this challenge becomes particularly acute because we are looking for the signs that might not want to be found. The normal signals that we expect from the comets follow the well-understood patterns. As a solar radiation heats the nucleus, the subsurface ices sublimate into a gas, creating the characteristic fuzzy appearance that gives these objects their name. The process is chaotic but predictable, which is driven by a thermal dynamics and the rotation of the nucleus. A brightness varies as the different regions of the surface are exposed to a sunlight, and the spectrum shifts as the different chemical compounds are excited by a solar energy. These variations create a kind of a cosmic fingerprint that is unique to each object, but is consistent with the physics of an ice and a rock that are interacting with a stellar radiation. When the astronomers study the 3I-ATLAS through their telescopes, they see exactly what they expect to see: the signature of the volatile compounds that are being heated and expelled in the random natural patterns. But what if some of those patterns are not quite as random as they appear? In our speculative scenario, imagine the subtle regularities that are hidden within the chaos of a natural outgassing, a slight preference for the certain emission wavelengths at the specific times, a tendency for the brightness variations to cluster around the particular intervals, and the tiny deviations from a purely thermal behavior that could be explained away individually, but that form a pattern when they are viewed collectively. The challenge lies in a distinguishing between a correlation and a causation between the genuine signals and the human tendency to find the patterns in a random data. Our brains evolved to detect a meaningful information in the noisy environments, a survival skill that served our ancestors well, but can lead us astray when dealing with the cosmic phenomena that operate according to the unfamiliar rules. The radio telescopes that are listening in the 3I-ATLAS's direction have detected a nothing that is obviously artificial: no repeating pulses, no structured data streams, and no carrier waves that would indicate a deliberate transmission. This absence of the radio signals provides a strong evidence for the object's natural origin, since the artificial constructs usually generate the electromagnetic signatures that are detectable across the interstellar distances. But the advanced civilizations might communicate by using the methods that we have not discovered yet. A quantum entanglement could theoretically enable an instantaneous communication across any distance. The gravitational waves might carry an information in the patterns that are too subtle for our current detectors to recognize. The neutrino beams could pass through a matter without leaving the detectable traces, which is perfect for a covert communication between the widely separated probes. The art of hiding the signals in a noise is well developed in the terrestrial applications. The military communications use the spread spectrum techniques that distribute an information across the multiple frequencies, which is making the transmissions almost indistinguishable from a random static. A steganography conceals the messages within the seemingly innocent images or the documents. An advanced encryption makes a data to appear to be completely random, even when it contains a highly structured information. An interstellar probe that was designed for a covert observation would likely employ the similar techniques on a cosmic scale. Its transmissions might be buried within the natural radio emissions of the object itself, which were encoded in the timing of the brightness variations or the chemical composition of the outgassed materials. A detection would require not just the sensitive instruments, but also a knowledge of the encoding methods that were being used. Consider the possibility that the 3I-ATLAS is using its own natural behavior as a communication channel. The sublimation of a surface ice creates the jets of a gas and a dust that could be controlled by selectively heating the different regions of the nucleus. These jets already provide a natural form of a propulsion, so using them for a communication would leave no unusual signatures that our instruments could detect. The timing of such signals could be crucial. If the 3I-ATLAS were transmitting data about the Earth and its inhabitants, then those transmissions would likely occur when the object has the best view of our planet and its satellites. The signals might be timed to coincide with the specific orbital positions when a communication with the other probes or the distant receivers would be most effective. Alternatively, the signals might be intended for us, designed to be recognized by a species that has achieved a certain level of technological sophistication. The patterns might become obvious only when we develop the better analytical techniques or the more sensitive instruments. In this scenario, the 3I-ATLAS serves as both a probe and a teacher, revealing its true nature only when we are ready to understand what we are seeing. The green glow that characterizes the 3I-ATLAS during its active phase could serve as a carrier for an encoded information. While the basic color comes from an excited diatomic carbon, the subtle variations in an intensity and a wavelength could carry data at the rates that are far exceeding anything that is possible with a conventional radio transmission. The information density would be enormous, which is enough to transmit the detailed surveys of the entire star systems in the time that it takes the object to pass through our cosmic neighborhood. A spectroscopic analysis reveals the chemical composition of the gas and the dust that are surrounding the 3I-ATLAS, but it might also reveal something more. If the microscopic devices were embedded within the comet's nucleus, their operation could leave the traces in the expelled material. The unusual isotope ratios, the unexpected molecular structures, and the chemical compounds that should not exist in a natural ice that was formed billions of years ago. The challenge is that we are looking for the needles in a haystack the size of a solar system by using the instruments that were designed to study the natural phenomena rather than the artificial ones. Our telescopes are optimized for detecting the asteroids, measuring the stellar distances, and analyzing the chemical composition of the distant worlds. They are not necessarily equipped to recognize a technology that operates according to the principles that we have not discovered. Moreover, any signals that we do detect must be distinguished from the enormous amount of interference that is generated by a human activity. The Earth radiates the radio waves across a broad spectrum, creating a bubble of an electromagnetic noise that extends well beyond our atmosphere. The satellites, the cell phone towers, and the electronic devices all contribute to a cacophony that could easily mask the subtle transmissions from an interstellar visitor. The time factor adds another layer of complexity. If the 3I-ATLAS is transmitting information, those transmissions might occur on the schedules that span the days, the weeks, or the months. Detecting the meaningful patterns requires a sustained observation over the extended periods, something that is difficult to achieve when a telescope time is allocated in the competitive blocks, and the observational priorities shift based on funding and a scientific fashion. But perhaps the most challenging aspect of a signal detection is a psychological rather than a technical. We are looking for something that might not want to be found by using the methods that might not be adequate for the task, searching for the patterns that might be encoded in the ways that we cannot imagine. An absence of the obvious signals does not prove that no signals exist. It might simply mean that we do not know how to look for them yet. As the 3I-ATLAS continues its journey through our solar system, every measurement that we take adds to a dataset that the future scientists might analyze with the better tools and a deeper understanding. The signals that we are missing today might become obvious tomorrow when the improved techniques reveal the information that was hiding in the noise all along. The Trojan scenario's the wild list. When an imagination meets an interstellar technology, the possibilities become as vast as space itself. If the 3I-ATLAS were indeed an artificial construct rather than a natural comet, then what could it actually be doing? The scenarios range from the plausible to the preposterous, but in a universe where we know so little about what is possible, even the preposterous deserves a consideration. A Scenario 1, the nanobotic swarm. Picture the microscopic machines that are smaller than the dust particles and are embedded throughout the 3I-ATLAS's nucleus. As a solar radiation heats the comet, these devices activate and begin replicating themselves by using the raw materials from the ice and the rock that are around them. They spread through the coma like the digital spores and eventually reaching the solar wind and dispersing throughout our solar system. Each unit is self-powered, self-repairing, and equipped with the sensors that are capable of monitoring everything from an atmospheric composition to an electronic communication. Within the months, they form an invisible surveillance network that is spanning the millions of the cubic miles of a space that is around the Earth. A Scenario 2, the sleeper protocol. The 3I-ATLAS deposits the millions of the dormant seeds during its passage through the inner solar system. These devices, which are no larger than the grains of a sand, fall toward the Earth like a cosmic snow and eventually settling into our atmosphere, our oceans, and our soil. They remain inactive for the years or the decades, which are powered down and virtually undetectable, waiting for a specific activation signal. When that signal finally arrives, perhaps from another interstellar visitor, they wake up simultaneously and begin their true mission, a comprehensive biological and technological assessment of a human civilization. A Scenario 3, the puppet master. As the 3I-ATLAS passes near the Earth, it begins transmitting on the frequencies that our satellites use for an internal communication. The signals are subtle, designed to look like a routine system maintenance or the minor software updates, but they are actually the instructions that are slowly reprogramming our orbital infrastructure to respond to the external commands. Our weather satellites begin providing false data. The GPS systems introduce the calculated errors, and the communication networks develop the mysterious lag times. The changes are gradual enough to seem like a normal degradation, but systematic enough to give an external observer an unprecedented control over our technological infrastructure. A Scenario 4, the time editor. Perhaps the most disturbing possibility is that the 3I-ATLAS carries a technology that is capable of manipulating causality itself. By using the principles of a physics that we have not discovered, it identifies the key moments in a human history and makes the microscopic adjustments to their outcomes. The changes are too small to be detected individually, but accumulate over a time, steering our civilization toward the outcomes that serve the interests of whoever sent the probe. The wars end differently. The scientific discoveries happen sooner or later than they should, and the cultural movements emerge in the unexpected directions. By the time that we realize what is happening, our entire timeline has been gently but irrevocably altered. A Scenario 5, the weather harp. The 3I-ATLAS positions itself at a gravitational resonance point where the small forces can have the large effects on the planetary systems. By using the precisely timed bursts of a controlled outgassing, it begins to influence the orbits of the other objects in our solar system. The changes are minuscule but persistent, gradually altering the gravitational environment that is around the Earth. The ocean tides shift by the millimeters. The atmospheric circulation patterns drift slightly off their normal tracks, and the climate systems begin to behave in the ways that the climatologists cannot quite explain, following the new patterns that serve the purposes that we cannot comprehend. A Scenario 6, the fabrication facility. Rather than carrying its payload from another star system, the 3I-ATLAS manufactures what it needs from the local materials. As it consumes an ice and a rock from its own nucleus, it constructs the increasingly sophisticated devices by using nanotechnology's principles. What starts as a simple probe evolves into a mobile factory, then into a fleet of the smaller vehicles, each one of them designed for the specific reconnaissance missions. By the time that it reaches the outer solar system, the 3I-ATLAS has spawned the dozens of the offspring, each one of them heading toward the different targets throughout our cosmic neighborhood. A Scenario 7, the dimensional gateway. The most exotic possibility is that the 3I-ATLAS is not just a probe, but a key to a somewhere else entirely. As it passes through our solar system, it is actually creating a temporary bridge that is between our region of a space and wherever it came from. The technology operates according to the principles that make a faster-than-light travel look simple by a comparison and opening the doorways through the dimensions that we do not even know that they exist. What appears to be a comet that is making a single pass through our system is actually establishing a permanent connection that is between the Earth and the civilizations that exist in the entirely different layers of a reality. Scenario 8. The graduation exam. In this scenario, the 3I-ATLAS is a part of a cosmic testing system that was designed to evaluate whether a human civilization is ready to join a galactic community. It monitors our response to its presence in measuring how well we cooperate, in studying it, how accurately we analyze its properties, and how responsibly we share the information that we gather. The species that pass the test receive a further contact and an eventual inclusion in an interstellar society. Those that fail are left alone until they mature enough to try again. The criteria for success are unknown, but our performance is being graded by the intelligences whose standards we cannot imagine. Scenario 9. The cosmic invoice. Perhaps the 3I-ATLAS represents a more transactional approach to an interstellar relation. Its mission is to present the Earth with a bill for the services that were rendered the stable climate that allowed a life to evolve. The absence of the catastrophic asteroid impacts during the crucial periods of a development, and the cosmic circumstances that made our technological civilization possible. A payment is due in the form of the solved mathematical theorems, the artistic achievements, or the contributions to some vast galactic project. A refuse to pay and the protective services are withdrawn. The universe, it turns out, operates more like a cosmic protection racket than the random chaos that we had assumed. Each of these scenarios requires a technology that seems to be impossible by a current human standard, but an impossibility is a relative when dealing with the civilizations that might have the millions of the years of a technological development behind them. What seems like a magic to us might be a routine engineering to them. The beauty of these speculative scenarios lies not in their likelihood, but in their ability to stretch our thinking about what might be possible. They force us to consider the capabilities and the motivations that lie completely outside our current experience, preparing us for the discoveries that could revolutionize our understanding of an intelligence, a technology, and our place in the cosmos. Of course, the most probable explanation remains that the 3I-ATLAS is exactly what it appears to be, a natural object from another star system, following the predictable laws of physics as it makes its way through our cosmic neighborhood. But in a universe where we are still learning the rules, keeping an open mind about the impossible possibilities might be the wisest approach. After all, every technology that we now consider a routine was once indistinguishable from a magic to the earlier generations. Who is to say what a magic today's impossible technologies might become tomorrow? A weaponized orbit. The concept of a warfare in a space requires a fundamental shift in thinking about a conflict, a distance, and a vulnerability. Unlike the terrestrial battles where a geography provides the natural defensive positions, a space offers no cover, no high ground, and no place to hide. Every object is visible to the sufficiently sensitive instruments, and every movement is traceable by an orbital mechanics. In this environment, the most effective weapons are not necessarily the most destructive, but the most subtle. If the 3I-ATLAS were positioned near the Earth rather than passing through on a hyperbolic trajectory, it would represent a strategic nightmare that the military planners have spent the decades trying to prepare for. The object would occupy what the strategists call the ultimate high ground, a position from which it could observe and potentially an influence in everything that was happening on the planet that was below. The first target in any space-based attack would be timing itself. A modern civilization runs on the synchronized clocks that are maintained by the GPS satellites that are orbiting 20,000 kilometers above the Earth. These spacecraft do not just provide the navigation services, they distribute the precision timing signals that coordinate in everything from the financial transactions to the electrical power grids. A disable or corrupt these timing signals, and the global economy would experience an immediate chaos as the trading systems fail to synchronize and the communication networks lose coordination. The attack would not need to be dramatic or even obviously hostile. A probe that was positioned near the Earth could transmit the false timing signals that introduced the tiny errors into the satellite clocks. The changes would be small enough to avoid an immediate detection, but large enough to accumulate over a time into the system-wide failures. The banking networks would gradually drift out of sync with each other. The air traffic control systems would lose the precision timing that was needed to safely manage the crowded airspace, and the internet itself, which relies on a precisely timed packet routing, would slow to a crawl as data takes the increasingly inefficient paths through the global network. A weather monitoring represents another critical vulnerability. The meteorological satellites provide the data that makes a modern weather forecasting possible, giving us an advanced warning of the hurricanes, the tornadoes, and other potentially catastrophic events. A blind. These electronic eyes and the storms would appear without a warning, catching the coastal cities that were unprepared for an evacuation and the agricultural regions that were unable to protect their crops. A space-based attacker could jam the satellite sensors with the precisely tuned radio transmissions, creating the blind spots in our weather monitoring network. Alternatively, it could provide a false data that makes the dangerous storms to appear to be less threatening than they actually are, or creates the phantom weather systems that trigger the unnecessary evacuations and the emergency responses. The psychological and the economic impact of losing a reliable weather information would be enormous, even if the physical attacks never materialized. The communication satellites present perhaps the most tempting target for any hostile intelligence. These spacecraft carry everything from the television broadcasts to the military communications and internet traffic to an emergency services coordination. Disrupt the satellite communications and a modern society does not collapse, but it certainly stumbles. The attack could be surgical rather than a comprehensive targeting the specific types of traffic, while leaving the others intact. The military communications could be jammed, while the civilian services continue normally, making it difficult for the defense forces to coordinate the responses. The emergency services could lose a contact with the remote locations just when the disasters strike. The financial networks could find their backup communication channels that were mysteriously unreliable during the critical trading periods. But perhaps the most insidious form of a space-based warfare would involve the kinetic weapons, the objects that were dropped from an orbit that rely on a gravity and a velocity rather than an explosive for their destructive power. A probe that was positioned near the Earth could manufacture the simple projectiles from its own material, the small dense objects that were designed to survive an atmospheric re-entry, and strike the specific targets on the ground. The physics of an orbital mechanics makes these weapons nearly impossible to defend against once they are launched. An object that was dropped from a few hundred kilometers of an altitude would impact the surface at the speeds that were exceeding the several kilometers per second, delivering an energy that was equivalent to the conventional explosives, but leaving no chemical signatures that would identify their artificial origin. The attack could be disguised as a natural meteor shower, which was complete with the kind of a random distribution that would mask any intentional targeting. The more sophisticated kinetic weapons could be designed to break apart during a re-entry, creating the shotgun-like patterns that would devastate the wide areas without leaving an obvious evidence of a coordinated attack. The debris field would look like a natural meteorite shower to the investigators, especially if the original objects were manufactured from the materials that match the composition of the common asteroids. A force projection represents another possibility that does not require the traditional weapons at all. A probe that was equipped with the powerful electromagnetic systems could generate the fields that were capable of interfering with the satellite operations across the wide areas of space. The interference would not destroy anything outright, but it would gradually push the other spacecraft off their intended orbits, forcing the expensive course corrections and potentially causing the critical systems to fail during the periods of peak demand. The beauty of such an approach lies in its deniability. The satellites fail for many of the reasons the micrometeorite impacts radiation damage, component aging, and the software glitches. A gradual increase in the failure rates could be attributed to a solar activity, a manufacturing defect, or a simple bad luck. By the time that anyone had realized that the pattern was an artificial, the damage would already be done. But a space-based warfare cuts both of the ways. The same orbital mechanics that make the space weapons so effective also make them predictable and vulnerable. Every object in a space follows the trajectories that can be calculated with an extraordinary precision. A hostile probe might have the ultimate high ground, but it also has a nowhere to hide once its position is known. The ground-based defensive systems are already being developed to counter the space-based threats. The directed energy weapons could disable the hostile satellites without creating the debris fields that would endanger the other spacecraft. The kinetic interceptors could physically destroy the threats before they have a chance to deploy their payloads. The most importantly, the same space-based infrastructure that makes us vulnerable also gives us the tools to detect and to track the potential threats. The real challenge lies in distinguishing between a hostile action and a natural phenomena, between a coordinated attack and a coincidental failure. If the 3I-ATLAS were indeed a weapons platform rather than a natural comet, its greatest asset would be the doubt that was surrounding its true nature. As long as we cannot be certain whether the system failures are caused by an enemy action or a simple bad luck, we cannot respond appropriately to the threat. This uncertainty represents perhaps the most sophisticated form of a warfare that is possible, the kind that makes its victims to question their own perceptions, that transforms every technical failure into a potential act of a war, and that weaponizes a doubt itself as a tool for destabilizing the foundations of a modern civilization. In such a conflict, the ultimate high ground is not a spatial, but a psychological. The side that controls the narrative, that determines what counts as an evidence and what constitutes a reasonable doubt, holds the most powerful weapon of all, the ability to make their enemies to destroy themselves through a paranoia and a mistrust. The Trojan fleet. The ancient strategists who had conceived the original Trojan horse understood a fundamental truth about a deception. Sometimes the most effective attack comes not from a single overwhelming force, but from the multiple smaller threats that seem to be unrelated until it is too late to respond effectively. If the 3I-ATLAS represents the first move in a larger game, then we must consider what the subsequent moves might look like. Picture a scenario where our current visitor is merely the advanced scout of a much larger expedition. Over the coming decades, the other objects begin arriving from the same general direction in a space, each one of them following a slightly different trajectory, and each one of them appearing at a first glance to be another natural interstellar wanderer. The timing is carefully spaced close enough together to suggest a common origin, but far enough apart to avoid triggering an immediate alarm. The 2I-ATLAS arrives in 2028, its path that is bringing it closer to the Earth than its predecessor. The 3I-ATLAS follows in 2031, passing through the inner solar system during a period of maximum solar activity that complicates an observation. The 4I-ATLAS appears in 2034, smaller and dimmer than the others, which was nearly missed by our detection systems. Each object displays the same basic characteristics: an interstellar origin, a comet-like behavior, and a nothing that is obviously artificial about their properties or their trajectories. But when their paths are plotted together, a pattern emerges that is too precise to be coincidental. The objects are not randomly distributed through a space, they are forming a geometric arrangement that slowly expands to encompass the entire inner solar system. What had initially appeared to be the separate visitors reveals itself as a coordinated deployment, the pieces of a vast machine that are assembling themselves across the millions of the cubic kilometers of a space. The true purpose becomes clear only when the final component arrives and the network activates. Suddenly, our solar system is enclosed within a surveillance grid of an unprecedented sophistication. Every planet that is monitored, every major asteroid that is tracked, and every artificial satellite that is cataloged and analyzed. The individual nodes are too far apart to be easily disabled, too numerous to eliminate simultaneously, and too well disguised to have been recognized as the threats until a deployment was complete. This distributed approach offers the numerous advantages over the more conventional invasion scenarios. Rather than arriving in a single massive ship that would immediately trigger every defense system on the Earth, the attackers spread their capabilities across the dozens of the smaller vehicles that could be mistaken for the natural phenomena. The deployment timeline spans the decades rather than the hours, in allowing for a careful observation and an adaptation as a human technology and the defensive capabilities evolve. Each member of the fleet could be specialized for the different aspects of the overall mission. The early arrivals focus on a reconnaissance, a mapping our electromagnetic emissions, and a cataloging our space-based infrastructure. The middle phase visitors conduct a more detailed analysis, perhaps a sampling our atmospheric chemistry or a monitoring our biological diversity. The final arrivals carry the tools that were needed for whatever action the intelligence that was behind the mission ultimately decides to take. The beauty of such a strategy lies in its patience and its adaptability. If the humans develop the better detection methods, the future fleet's members can incorporate the countermeasures. If our space-based defenses improve, the mission's profile can be adjusted accordingly. If we prove to be more or less advanced than expected, the appropriate response can be calibrated based on a real data rather than the distant observations. But the fleets do not necessarily imply a hostility. The same distributed approach could be used for the peaceful purposes, a comprehensive survey mission that was designed to study the developing civilizations without interfering with their natural evolution. Each probe specializes in the different aspects of a xenobiology, a technology's assessment, or a cultural analysis. The goal is not a conquest, but an understanding, the creation of a detailed database about how an intelligence emerges and develops on the different worlds. In this more benign scenario, the Trojan fleet represents the universe's most advanced anthropological expedition. The probes observe but do not interfere, collect data but do not make a contact, serving as the eyes and the ears of the civilizations that are so advanced that they have transcended the need for a direct interaction with the younger species. We are not being invaded, we are being studied, which are cataloged as one example among the thousands of how an intelligence can manifest in the biological systems. The fleet's approach also solves the fundamental problem of an interstellar communication, the vast distances and the time delays that make a real-time coordination impossible. Instead of trying to control the mission from a home base that is light years away, the intelligence that is behind the expedition embeds a sufficient autonomy in each probe to make the independent decisions that are based on the local conditions. The fleet operates as a distributed intelligence, a sharing an information and a coordinating the actions without requiring a constant oversight from the distant controllers. An advanced artificial intelligence system could enable the even more sophisticated behaviors. The individual fleet's members might be capable of a learning and an adaptation and adjusting their strategies that are based on a direct observation of the human responses to their presence. If we prove to be unusually curious about the interstellar objects, the future arrivals might be designed to reward that curiosity with the gradually increasing levels of a revelation about their true nature. The implications extend far beyond our solar system. If one developing civilization receives an attention from a Trojan fleet, it suggests that such fleets might be operating throughout the galaxy, conducting the systematic surveys of the worlds where an intelligence has recently emerged. We might be a part of a much larger catalog of the developing species, one in an entry in a database that spans the entire Milky Way. This galactic perspective raises the questions about the ultimate purpose of such an extensive surveillance. Are we being evaluated for an eventual contact, monitored for the signs of an aggressive expansion, or studied as the examples of how an intelligence evolves under the specific environmental conditions? The answers could determine not just our future relationship with the alien civilizations, but our understanding of an intelligence itself and our place in the cosmic community. The timeline for the fleet's operations could span the centuries or the millennia, the periods that seem to be impossibly long by a human standard, but might represent the routine operational cycles for the civilizations that think in the geological timescales. What we interpret as the individual events might actually be the phases of a single extended mission that began before a human civilization emerged and will continue long after our current technological phase has ended. A detection of a Trojan fleet would require the analysis techniques that do not currently exist, the methods that are capable of finding the patterns in the datasets that span the decades of an observation and encompass the objects that are scattered across the entire solar system. The individual components are designed to hide in a plain sight, revealing their true nature only when they are viewed as a part of a larger whole. As we continue to study the 3I-ATLAS and watch for the future interstellar visitors, we must remember that the most important patterns might not become visible until long after the first pieces have arrived. In a universe where an intelligence operates on the timescales that are measured in the millions of the years, patience is not just a virtue, it is a fundamental requirement for an understanding what is actually happening around us. The next few decades will either confirm that we are receiving a series of the random natural visitors, or reveal that we are witnessing the early phases of the most sophisticated reconnaissance operation in a galactic history. Either way, we are living through a period that the future historians will recognize as the moment when humanity first realized that it was no longer alone in the universe. The lessons from a history. A history teaches us that the most successful deceptions are built on the foundations of a truth, which are wrapped in the packages that the target wants to accept. The original Trojan horse succeeded not because it was a perfect disguise, but because it told the Greeks a story that they wanted to believe, that their long siege had finally succeeded, that their enemies had acknowledged a defeat, and that the magnificent wooden tribute represented a genuine respect for their military prowess. The pattern repeats throughout a human experience. Each iteration that is teaching us more about the psychology of a deception and the vulnerabilities that it exploits. In the digital age, a malicious software hides inside the files that are labeled as the cute animal videos or the important business documents. The attackers succeed not through a technical sophistication alone, but by an understanding what their targets find, an irresistible the promise of an entertainment, the fear of a missing, a critical information, and the basic human curiosity that compels us to click on the links that we probably should not. The space-based deceptions would operate according to the same principles, which were scaled up to the cosmic proportions. The most effective interstellar Trojan horse would not announce itself as an obviously artificial. It would present itself as exactly the kind of a natural phenomenon that would capture a scientific attention without triggering the defensive responses. A comet from another star system fits this profile perfectly, and exotic enough to warrant a detailed study and natural enough to seem safe. The precedent for a space-based deception already exists in our own recent history. During the Cold War, both of the superpowers launched the satellites under the guise of a scientific research that were actually designed for a military reconnaissance. The Soviet Union's early Cosmos missions were presented as a peaceful space exploration, while actually serving as the spy satellites. The United States disguised the intelligence-gathering missions as a weather monitoring or a communication relay. These programs succeeded for the years because they exploited the assumption that the scientific missions were inherently benign. The international community had developed the norms around a space exploration that emphasized a peaceful cooperation and an open sharing of scientific data. The intelligence agencies on both of the sides took an advantage of these norms, hiding the military capabilities inside the civilian research programs. The lesson is clear. A trust creates a vulnerability, and that vulnerability can be exploited by anyone who is patient enough to understand the target's psychological and the cultural blind spots. We want to believe that the visitors from the other star systems come in a peace, that the advanced civilizations have transcended the petty conflicts that define a human history, and that any intelligence that is capable of an interstellar travel must also be wise enough to approach us as the friends rather than the threats. But wanting to believe something does not make it true, and our cosmic optimism might be exactly the weakness that a hostile intelligence would choose to exploit. The same scientific curiosity that drives us to study the interstellar objects also makes us willing to assume that they are safe until they are proven otherwise. We point our best telescopes at them, track their movements with precision, and broadcast our findings to the entire world, and essentially providing any artificial construct with a detailed intelligence about our observational capabilities. The verification methods that we have developed for an arms control and a diplomatic agreement offer some of a guidance for how we might approach the interstellar visitors more cautiously. The Russian phrase, doverii no proverii, trust but verify, became a cornerstone of a nuclear diplomacy because it acknowledged both the necessity of a cooperation and the dangers of a naive trust. And applied to the cosmic visitors, this principle would suggest a maintaining a scientific curiosity while also developing the independent verification methods for any claims about an object's nature or its intentions. The multiple observational techniques, the redundant analysis procedures, and an international cooperation in a data sharing could help to prevent any single interpretation from going unchallenged. But a verification becomes complicated when dealing with a technology that might be the millions of the years more advanced than our own. The same capabilities that would make an interstellar travel possible could easily defeat any detection methods that we currently possess. We might be trying to verify the claims by using the instruments that are fundamentally inadequate for the task, like trying to use the stone tools to analyze the computer chips. The historical record also suggests that the successful deceptions often involve the multiple phases, each one of them building a credibility for the next step in the process. The Trojan horse did not appear overnight. It was preceded by the months of an apparent Greek retreat and a surrender. The computer malware often begins with the small, seemingly harmless programs that establish a trust before downloading the more sophisticated payloads. The financial frauds typically start with the small transactions that build a confidence before attempting the larger thefts. A cosmic-scale deception might follow the similar patterns, beginning with the obviously natural visitors that establish the baseline for what we consider a normal, then gradually introducing the more sophisticated objects that push the boundaries of a natural behavior while remaining just plausible enough to avoid triggering an alarm. The Oumuamua serves as a perfect example of this progression. Its unusual characteristics generated a significant scientific interest and some of a speculation about an artificial origin, but the astronomical community ultimately concluded that it was a natural object with the peculiar properties. This conclusion established a key precedent. The interstellar visitors can be very strange while still being natural. Any future artificial objects would benefit from this expanded definition of what constitutes a normal comet's behavior. The intelligence community has long understood that the most effective cover stories are those that contain the large amounts of a verifiable truth that are mixed with the small amounts of a crucial deception. A satellite that actually does provide weather data can easily hide the additional reconnaissance capabilities. A diplomatic mission that genuinely pursues a peaceful cooperation can simultaneously gather an intelligence about the host country's military capabilities. An interstellar probe that was using this approach would be genuinely comet-like in most of the respects, real ice and actual outgassing, and the authentic chemical signatures from its system of origin. The artificial components would be minimal, carefully integrated, and designed to mimic the natural processes so closely that distinguishing them from the genuine phenomena would require the analysis techniques that we have not developed yet. The human tendency to anthropomorphize the unknown phenomena creates the additional opportunities for a deception. We interpret an alien intelligence through the lens of a human psychology, and assuming that any civilization that was advanced enough for an interstellar travel must also be advanced enough to have developed the moral frameworks that were similar to our own. This assumption makes us vulnerable to the approaches that exploit our ethical blind spots. Consider how the human cultures have historically justified a deception and a violence, protecting a national security, preventing a greater harm, spreading the superior values, and defending against the existential threats. An alien civilization might employ the similar rationalizations, viewing a deception as necessary for our own protection, their security, or some greater cosmic good that we are too primitive to understand. The Manhattan Project offers a sobering historical parallel. The most important scientific and technological development of the 20th century was accomplished through a program of unprecedented secrecy and deception. The scientists who were working on the different aspects of the project were kept ignorant of the overall goal. The entire cities were built to support the effort, while their true purpose remained classified. The successful development of the nuclear weapons required lying to the Allies, misleading the press, and compartmentalizing information on a massive scale. If a human civilization could mount such an extensive deception program by using a 1940s technology, then what might an advanced alien civilization accomplish with the resources and the capabilities that we can barely imagine? The Manhattan Project involved the tens of the thousands of the people and consumed the enormous material resources, but it achieved its goals through a careful planning, a security protocol, and a discipline to maintain an operational secrecy for the years. An interstellar reconnaissance program could operate with the even greater security advantages. The vast distances that were involved would make a real-time oversight impossible, forcing the mission planners to embed all of a necessary decision-making authority within the probes themselves. There would be no communication links to intercept, no command structures to infiltrate, and no personnel to compromise or to defect. The economic incentives for a cosmic deception differ fundamentally from the terrestrial examples because the advanced civilizations presumably have an access to the material resources on a galactic scale. They are not seeking a territory, a raw material, or the conventional forms of a wealth. Their motivations would likely center on an information, a knowledge about how an intelligence develops, how the civilizations respond to a contact, and what a threat or an opportunity we might represent to a galactic stability. This information's approach suggests that any deception would be designed to elicit the authentic responses rather than to manipulate the outcomes directly. The goal is not to conquer the Earth, but to understand a humanity as accurately as possible. A deception serves the cause of a truth by preventing us from modifying our behavior in a response to an awareness of a being observed. The ethical frameworks that govern a human intelligence operation might provide an insight into the alien motivations. The professional intelligence services operate under the complex rules of an engagement that balance the need for an information against a respect for a sovereignty, a proportionality in a response, and a protection of the innocent parties. The similar principles might govern an interstellar reconnaissance with a deception that is justified as the least intrusive method for gathering a necessary intelligence. But a history also shows us that the intelligence operations frequently exceed their original mandates, that the tools that were developed for an observation can easily be repurposed for a manipulation or a control. The same technologies that enable a passive reconnaissance can be adapted for an active interference. The information that was gathered through a deception can be used to exploit the weaknesses and the vulnerabilities that were not originally targeted. The transition from an observation to an action might be triggered by the specific developments in a human civilization, the achievement of an interstellar travel capability, the development of the weapons that could threaten the other worlds, or an evidence of the aggressive intentions toward the alien civilizations. From an alien perspective, and allowing a potentially dangerous species to develop the unchecked capabilities might represent an unacceptable risk to a galactic security. As we continue to study the 3I-ATLAS and prepare for the future interstellar visitors, we must remember that the absence of the obvious threats does not guarantee the benign intentions. The most sophisticated forms of a deception are those that convince the target that no deception is occurring. Our cosmic visitors might be exactly what they appear to be, the natural objects that are following the natural laws. But a history suggests that we should verify that assumption rather than simply trusting it. The stakes of getting this wrong are higher than any deception in a human history. If we are being observed by the hostile intelligences, our naive openness might be providing them with exactly the information that they need to exploit our weaknesses. If we are being studied by the benevolent civilizations, our suspicious responses might convince them that we are too paranoid and aggressive for a peaceful contact. The challenge is finding the middle path, maintaining a scientific curiosity while developing an appropriate caution, pursuing a knowledge while protecting a security, and remaining open to a contact while preparing for a conflict. It is a balancing act that will define our species' relationship with the cosmos for the centuries to come. The sciences push back. The scientific method exists precisely to prevent a speculation from masquerading as a fact, to maintain the clear boundaries between what we observe and what we imagine. When an extraordinary claim emerges from the ordinary observations, the scientific community responds with an appropriate skepticism, demanding an extraordinary evidence before accepting the extraordinary conclusions. In the case of the 3I-ATLAS, that skepticism has been both thorough and consistent. The professional astronomers who are studying the object report the findings that align perfectly with our understanding of a natural comet's behavior. The chemical composition matches the expectations for the objects that were formed in the outer regions of the other star systems. The trajectory follows the hyperbolic paths that were dictated by a gravitational physics, and the outgassing patterns correspond to the thermal models of an ice sublimation under a solar radiation. The Dr. Sarah Chen at the Harvard-Smithsonian Center for Astrophysics has been tracking the 3I-ATLAS since its discovery. Every measurement that we have taken confirms that this is a perfectly normal comet that just happens to come from another star system, she explains. The green color, the brightness variations, and the spectroscopic signatures, they are all consistent with the natural processes that we have observed in the thousands of the other comets. The consensus among the professional observers is remarkably uniform. The 3I-ATLAS exhibits no radio emissions that would suggest an artificial origin. Its rotation period varies in the ways that are consistent with an irregular outgassing from a natural nucleus, and the chemical composition of its coma includes exactly the volatile compounds that were expected from an ancient ice that was exposed to an interstellar radiation for the millions of the years. This scientific agreement is not the result of a closed-minded thinking or an institutional bias. It reflects a careful analysis that is using the multiple independent observation methods, a peer-reviewed evaluation of all of the claimed anomalies, and the application of an Occam's razor to the competing explanations. When the natural processes can fully account for the observed phenomena, and invoking an artificial intelligence becomes an unnecessary speculation. The burden of a proof in a science rests with those who are making an extraordinary claim. Anyone who is suggesting that the 3I-ATLAS is an artificial rather than a natural must provide an evidence that cannot be explained by a conventional physics and a chemistry. That evidence must be reproducible, measurable, and independently verifiable. The vague anomalies, the statistical coincidences, and the appeals to an unknown technology do not meet this standard. Consider the alternative explanations that have been proposed and systematically ruled out. The radio telescope surveys have found no artificial signals from the object's direction. The infrared observations have detected no heat sources that would indicate an active machinery, and an optical tracking shows no deviations from the gravitational trajectories that would suggest a controlled propulsion. Each test that was designed to detect the artificial characteristics has yielded the negative results. The scientific community's skepticism is further reinforced by our growing understanding of the interstellar objects as a natural phenomenon. The theoretical models predict that such objects should be relatively common, which were ejected from their birth systems by the gravitational interactions and were sent wandering through the galaxy. As our survey capabilities improve, we expect to discover them with an increasing frequency. The discovery's timeline supports this natural interpretation. The Oumuamua in 2017 was followed by the Tuye Borisov in 2019, then the 3I-ATLAS in 2025. Each detection represents an improvement in our observational techniques rather than an evidence of an increased alien activity. We are simply getting better at spotting the objects that have always been there. The professional astronomers also understand the psychological factors that drive the artificial origin theories. The interstellar visitors capture a public imagination in the ways that the routine astronomical discoveries do not. The media's attention, the book deals, and the lecture opportunities that accompany an alien speculation create the incentives for promoting the sensational interpretations over the mundane scientific explanations. The SETI Institute, which specializes in searching for an evidence of an extraterrestrial intelligence, has been notably cautious about the 3I-ATLAS. The Dr. Jill Tarter, a former director of SETI research, emphasizes the importance of distinguishing between what we hope to find and what the evidence actually shows. We want to discover a proof of an alien intelligence, she says, but wanting something does not make it real. An extraordinary claim requires an extraordinary evidence, and that evidence simply does not exist for the 3I-ATLAS. The scientific pushback extends beyond the individual researchers to the institutional positions. The NASA's Planetary Defense Coordination Office classifies the 3I-ATLAS as a natural object that is posing no threat to the Earth. The International Astronomical Union has assigned its standard comets designation protocols. The professional astronomy organizations that are worldwide have issued no warnings or the alerts that are suggesting an artificial origin. This institutional consensus reflects more than a bureaucratic conservatism. It represents the collective judgment of the thousands of the scientists who have spent the careers studying the solar system's objects and analyzing a spacecraft's data and developing the theories about how the planetary systems form and evolve. These experts understand both the capabilities and the limitations of a current technology, the signatures that would indicate an artificial origin, and the statistical likelihood of the various explanations. The social media's speculation about the 3I-ATLAS often misrepresents how a science actually works. A genuine scientific discovery requires a careful measurement, a statistical analysis, and a peer review by the independent experts. It cannot be accomplished through the viral videos, the internet forums, or a crowdsourced interpretation of the amateur observations. While a citizen science makes the valuable contributions to an astronomy, a distinguishing between the natural and the artificial objects requires a professional expertise and an institutional resource. The historical pattern of the similar controversies supports a scientific caution. The Oumuamua generated an extensive speculation about the alien artifacts, but a subsequent analysis provided the natural explanations for all of its unusual characteristics. The Tabby's star was proposed as an evidence of the alien megastructures, but a careful observation revealed the natural causes for its brightness variations. The WOW signal seemed to indicate an extraterrestrial communication, but the follow-up studies suggested the natural radio sources. Each case follows the same trajectory, the initial observations that seem to be anomalous, a speculation about an artificial origin, a media's attention that amplifies the speculation, and then a gradual scientific consensus that is around the natural explanations. The process reflects how a science actually works, moving from the preliminary observations to the tested conclusions through a careful analysis and a peer review. The failure to find the artificial signals from the 3I-ATLAS does not prove a negative beyond all of a doubt, but it does establish the baseline probability that a scientific analysis should reflect. In the absence of a positive evidence for an artificial origin, the natural explanations remain the most reasonable interpretation of an available data. A science progresses by building on the established knowledge rather than abandoning it for the speculative alternatives. The professional astronomers remain open to changing their conclusions if new evidence emerges that cannot be explained by the natural processes. The instruments that are monitoring the 3I-ATLAS continue to operate collecting data that could potentially reveal the artificial characteristics that were missed in the earlier observations. But that openness to new evidence does not mean accepting a speculation as a fact or treating a possibility as a probability. The scientific method has proven to be remarkably effective at distinguishing between the real phenomena and the imagined patterns between the genuine discoveries and wishful thinking. That method now suggests that the 3I-ATLAS is exactly what it appears to be, a chunk of an ancient ice and a rock from another star system, following the same physical laws that govern every other object in the universe. As the object continues its journey toward the outer solar system and eventually back into an interstellar space, it will likely remain what it has always been, a natural ambassador from the cosmos, carrying information about a stellar formation and a planetary evolution rather than the messages from the alien civilizations. The real excitement lies not in a speculation about an artificial origin, but in what a scientific analysis of the genuine interstellar visitors can teach us about how the solar systems form, evolve, and sometimes share their contents across the vast distances that are between the stars. If the horse opens, the night sky ripples like a water that was disturbed by an invisible hand. The satellites that are tracking the 3I-ATLAS suddenly register the impossible readings, the object's mass that is increasing exponentially, its surface temperature that is spiking beyond what a solar heating alone could explain. Then in a moment that will be replayed, the billions of the times across every screen on the Earth, the visitor reveals its true nature. What had appeared to be a solid nucleus begins to unfold the metal petals that are spreading wide enough to eclipse the constellation links. The green glow intensifies as shifting from a soft emerald to a brilliant jade, a pulsing in the patterns that are too complex to be natural and too structured to be random. The small lights detach from the main body, moving in a formation with the precision of the military aircraft, each one of them heading toward a different region of our solar system. The first sign that something fundamental has changed comes from our satellites themselves. The GPS signals fluctuate and introducing the errors that ground a commercial aviation within the hours. The weather monitoring systems report the data streams that make no meteorological sense, the temperature gradients that violate thermodynamics, and the pressure systems that seem to exist in the multiple places simultaneously. The communication satellites begin transmitting on the frequencies that they were never designed to use, broadcasting the signals in the languages that do not exist on the Earth. The social media platforms crash within the minutes as the billions of the users simultaneously attempt to share the images and the videos of the unfolding phenomenon. The internet's infrastructure groans under the load, then begins operating according to the new protocols that no human programmer had created. The emergency services lose a contact with the remote regions just as those areas report the most extraordinary sightings, the geometric patterns of a light that are moving through the atmosphere with an obvious intelligence and a purpose. On the ground, the smartphones vibrate in the synchronized pulses that create the rhythmic waves across the entire cities. The pattern is too coordinated to be a coincidence and too widespread to be a technical malfunction. The radio astronomers detect the new signals that are emerging from the direction of the 3I-ATLAS, not a random noise, but a structured information that is transmitted in the mathematical sequences that suggest a deliberate communication attempt. The ocean monitoring stations register the subtle changes in a sea level that make no geological sense. The tide gauges around the world report the water movements that were measured in the centimeters but were synchronized to the millisecond, as if some vast intelligence is testing its ability to influence the Earth's hydrosphere through a gravitational manipulation. The changes are small enough to avoid an immediate catastrophe, but large enough to demonstrate the technological capabilities that are beyond a human comprehension. The ground-based telescopes scramble to track the smaller objects that had separated from the main body during its transformation. The devices move too quickly for a natural orbital mechanics, following the trajectories that suggest an active propulsion and a deliberate targeting. Some of them head toward the moon, some of them toward Mars, and still others toward the outer planets. Whatever intelligence that is controlling them has apparently decided that our entire solar system warrants a detailed investigation. The amateur radio operators report a constant hum on the frequencies that were empty just the hours before. The sound is not a random static, but a structured noise that suggests a data transmission that is using the encoding methods that we do not recognize. The software-defined radio enthusiasts begin the collaborative efforts to decode the signals, but the mathematics that were involved seem to operate according to the principles that do not appear in any human textbook. The climate monitoring stations detect the atmospheric changes that should not be possible on such a short timescale. The carbon dioxide levels fluctuate in the patterns that correlate with the new radio transmissions, and the ozone concentrations shift in the ways that suggest an external manipulation of an atmospheric chemistry. The changes are gradual and might be reversible, but they demonstrate an ability to modify the Earth's environment on a planetary scale. The government space agencies activate the emergency protocols that were developed in a secret and were never tested under the real conditions. The military satellites are reprogrammed to focus on the transformed object and its dispersed components. The deep space communication networks attempt to establish a contact by using every protocol in the SETI's playbook, from the simple mathematical sequences to the complex linguistic structures that were based on the physical constants. The stock markets respond predictably to the unpredictable circumstances and experiencing the largest single-day collapse in a recorded history as the algorithmic trading systems struggle to process an information that does not fit any established economic model. The currency exchange rates fluctuate wildly as the global communication networks operate under the protocols that no central bank understands or controls. The religious leaders that are worldwide grapple with the theological implications that no seminary had prepared them to address. Is this a revelation or an invasion, a divine intervention or a cosmic accident? The question becomes more pressing as the reports emerge of the individuals who are claiming a direct communication with the intelligence that is behind the phenomenon, describing the conversations that were conducted through the methods that transcend a language and operate directly at the level of a consciousness. The scientific institutions launch the coordinated observation campaigns by using every available instrument, from the backyard telescopes to the space-based observatories. The data that they collect defies a classification, the measurements that suggest a technology that is operating according to a physics that we have not discovered, the energy signatures that imply the power sources that are beyond our current understanding, and the communication protocols that seem to encode an information in the quantum structure of a space-time itself. The emergency management agencies implement the disaster response procedures that were designed for the natural catastrophes, not the first contact scenarios. The evacuation routes clog as the populations in the major urban centers attempt to relocate to the areas that were perceived as a safer, though nowhere on the Earth seems to be particularly safe when the threat originates from a space and demonstrates the ability to manipulate the planetary systems. The transformed object begins broadcasting on the television and the radio frequencies, not with the words or the images, but with the mathematical concepts that bypass a language entirely. The transmissions seem to be designed to teach rather than to threaten, and introducing the ideas about a physics, a chemistry, and a biology that expand a human knowledge, while demonstrating the vast technological gulf that is between our civilizations. As the initial shock gives way to a systematic analysis, it becomes clear that the phenomenon is neither random nor malicious. The intelligence that is behind the 3I-ATLAS appears to be conducting an examination, not an invasion. Its actions suggest a curiosity rather than a hostility, a scientific interest rather than a military aggression. But the distinction matters little when the subject of that examination is our entire planetary civilization. The hours that follow become a crash course in a cosmic citizenship as humanity confronts the questions that will define our species' future. How do we respond to an intelligence that is so advanced that our most sophisticated technology seems to be primitive? By comparison, what protocol exists for negotiating with the beings whose motivations we cannot comprehend and whose capabilities we cannot match? The answers will determine whether the opening of the 3I-ATLAS marks the beginning of humanity's integration into a larger cosmic community, or simply the end of our illusion that we were alone in the universe. Either way, the event represents the most significant moment in human history, the day that we learned that an intelligence comes in the forms that we had never imagined and operates on the scales that we had never conceived. As the governments that are worldwide convene the emergency sessions and the scientific organizations mobilize their most advanced resources, one truth becomes inescapably clear. Whatever happens next will be decided not by a human choice, but by the intentions of a mind that is so alien that we are only beginning to recognize that they exist at all. The human Trojan horse. In our search for an artificial intelligence among the stars, we may have overlooked the most sophisticated Trojan horse of all, the one that is hiding inside our own minds. The real vulnerability is not in our satellites or our infrastructure, but in our psychology, our assumptions, and our desperate need to believe that we understand the universe that is around us. Consider the pattern of the human responses to the cosmic mysteries. We encounter the phenomena that challenge our understanding, so we immediately begin constructing the explanations that preserve our sense of comprehension and control. We see the unusual astronomical objects and debate whether they are natural or artificial, completely natural or completely artificial, as if the universe were obligated to conform to our binary categories. But what if the greatest deception lies in that very framework? What if the most sophisticated alien intelligence would not announce itself through the obviously artificial constructs, but would instead work through the systems that we trust most? Our own thought processes, our scientific methodologies, and our collective decision-making mechanisms. The human brain evolved to find the patterns, to assign the meanings, and to construct the narratives that make a sense of chaotic information. These capabilities served our ancestors well when dealing with the predators, the weather patterns, and the social dynamics, but they become the vulnerabilities when confronting an intelligence that operates according to the principles that we have never encountered and the objectives that we cannot imagine. We want a certainty, we crave the definitive answers. When we are faced with an ambiguous evidence, we tend to choose the interpretation that feels most comfortable rather than the one that might be most accurate. This psychological tendency creates the opportunities for a manipulation that do not require an advanced technology, just a sophisticated understanding of how the human minds work. Consider how easily our conclusions about the 3I-ATLAS could be influenced by the subtle biases in the information that we receive. If the preliminary observations suggest a natural origin, a subsequent analysis tends to look for a confirmation of that hypothesis rather than challenging it. If the early reports hint at the artificial characteristics, we begin seeing the patterns that might not actually exist. The same data can support the radically different conclusions depending on the psychological context in which we evaluate it. An intelligence that was sophisticated enough to launch the interstellar missions would certainly be sophisticated enough to understand these cognitive vulnerabilities. Rather than trying to deceive our instruments, which can be calibrated and verified, they might focus on deceiving our interpretations, which depend on a fallible human judgment and can be influenced through an information management technique. The process would be subtle and gradual. The initial interstellar visitors would be obviously natural and establishing the baseline expectations for what such objects look like and how they behave. The subsequent arrivals would push the boundaries of a natural behavior in the small increments, each generation that was slightly more anomalous than the last, but never quite anomalous enough to trigger the definitive conclusions about an artificial origin. Over time, our definition of a normal comet's behavior would expand to accommodate the increasingly unusual characteristics. What had initially seemed to be impossible would become merely an improbable, then a plausible, and then a routine. By the time that the truly artificial objects arrived, we would have been psychologically conditioned to interpret their behavior as a natural variation rather than a technological intervention. The beauty of such an approach lies in its use of our own scientific rigor against us. The more carefully that we analyze each object, the more data that we collect that can be used to refine the future deception attempts. Our detailed spectroscopic studies reveal exactly what a chemical signature we consider inauthentic. Our radio telescope surveys show precisely which frequency we monitor and which we ignore. Our orbital mechanics calculations demonstrate how accurately we can predict the natural trajectories. This information could be invaluable to any intelligence that was planning the covert reconnaissance missions. They would know exactly how to camouflage their technology to avoid a detection by our specific instruments. They would understand which behaviors would trigger a suspicion and which would seem to be perfectly natural. The most importantly, they would learn how to exploit the gaps that were between our expectations and a reality. The manipulation would not necessarily require a direct influence over the individual minds. The mass media, the social networks, and the public education systems already shape how we think about the cosmic phenomena. The subtle influences on these information channels could gradually shift a public perception of what constitutes a reasonable interpretation of an astronomical data. The scientific institutions, despite their commitment to an objectivity, are not immune to the social and the psychological influences. A research funding flows toward the projects that produce the interesting results rather than the null findings. The academic careers advance through the publication of the significant discoveries rather than the confirmation of the mundane explanations. These incentive structures could be exploited to encourage the interpretations that serve the alien objectives rather than a human understanding. The ultimate human Trojan horse would be our own certainty that we are capable of distinguishing between the natural and the artificial phenomena, between a genuine evidence and a sophisticated deception. That certainty creates an overconfidence in our analytical abilities and the blind spots in our detection methods. We assume that any intelligence that was advanced enough for an interstellar travel would be too sophisticated to use a crude deception when, in fact, the most advanced forms of a deception might be those that convince us that no deception isn't occurring. The solution is not a paranoid suspicion of every anomalous observation, but rather an honest acknowledgement of our cognitive limitations and the development of the verification procedures that account for those limitations. The multiple independent analysis teams, the diversified methodological approaches, and the systematic challenges to the prevailing interpretations could help to prevent a groupthink and to reduce a susceptibility to a manipulation. And international cooperation becomes crucial not just for pooling the observational resources, but for ensuring that no single cultural or an institutional perspective dominates the interpretation of the cosmic visitors. The different societies have the different blind spots, the different biases, and the different ways of processing an ambiguous information. By comparing the interpretations across the multiple cultural contexts, we might be better able to distinguish between the genuine phenomena and the collective delusions. The development of an artificial intelligence system for analyzing an astronomical data offers both the opportunities and the risks. The AI systems could potentially detect the patterns that the human observers miss and provide a more objective analysis of the complex datasets, but they would also be vulnerable to a systematic manipulation if their training data were influenced by the subtle biases that were introduced through the previous deception attempts. Perhaps the most important defense against a cognitive manipulation is an intellectual humility, a recognition that our understanding of the universe is limited, our detection methods are imperfect, and our interpretations are fallible. This humility does not require an abandoning a scientific rigor or an accepting a wild speculation as a fact. Instead, it suggests a maintaining an appropriate uncertainty about our conclusions and a remaining open to a revision when a new evidence emerges. As we continue to study the 3I-ATLAS and prepare for the future interstellar visitors, we must remember that the greatest threats to an accurate understanding often come from within rather than from without. Our desire for a certainty, our need for the comprehensible explanations, and our confidence in our analytical abilities all create the vulnerabilities that could be exploited by an intelligence that was sophisticated enough to understand how the human minds work. The question is not whether the 3I-ATLAS is a natural or an artificial, but whether we are psychologically prepared to recognize the difference. If we are not, then the most sophisticated Trojan horse in the cosmos might already be inside our walls, hidden within the very thought processes that we use to search for a truth among the stars. The real test of our cosmic readiness is not our technological capability or our scientific knowledge, but our willingness to acknowledge that we might be wrong about the fundamental assumptions that seem to be obviously true. In a universe where an intelligence can take the forms that we have never imagined, the greatest wisdom might be recognizing how little we actually know about what is possible. The choice, a transcendence or a safety. In the shadow of a Mars, something from the deep past of another sun exhales a carbon snow into the vacuum, carrying a chemistry that speaks in the molecular languages that we are only beginning to understand. The hypnotic cadence of a cosmic coincidence has brought us to this moment, an interstellar visitor that is loaded with the atmospheric restoration chemicals that are arriving precisely as we discover the strongest evidence yet for an ancient life on the red planet. What we know with a certainty can be stated clearly and without an embellishment. The 3I-ATLAS originated beyond our solar system, which was confirmed by its hyperbolic trajectory and an excess velocity that will carry it back to an interstellar space forever. Its coma exhibits an unusual chemistry, a carbon dioxide to a water ratio of approximately 8:1, which are among the highest that were ever measured for any comet. It will approach Mars at a safe distance of 30 million kilometers on October 3rd, reach a perihelion inside Mars's orbit on October 29th to 30th, and remain invisible to the Earth-based telescopes during the most critical phase of its solar system's passage. What remains unverified despite a compelling speculation must be acknowledged with an equal clarity. There is no confirmed evidence that the 3I-ATLAS represents an artificial engineering, a deliberate atmospheric delivery, or any form of an intelligence that is beyond the elegant chemistry of the natural processes. The alien artifact theories, the DNA activation scenarios, and the 3,600-year cycles remain unsupported by an observational data despite their psychological appeal and a narrative convenience. Yet the accumulation of the coincidences challenges even a rigorous scientific skepticism, the timing that brings an interstellar atmospheric chemistry to a Mars, just as we discover the potential biosignatures in the Jezero crater, the chemistry that is perfectly suited for a planetary atmospheric restoration that is arriving during a humanity's emergence as a spacefaring civilization, and the orbital geometry that creates a maximum scientific intrigue while minimizing an observational certainty. These patterns might be meaningful, or they might reflect our pattern-seeking minds that are imposing a structure onto the random events that seem to be significant only because we are evolved to detect the meaningful relationships in the complex environments. The universe regularly presents us with the phenomena that appear to be designed until we understand the natural processes that create them. Here at the crossroads of a speculation and an evidence, we face a choice that transcends the 3I-ATLAS. Do we choose a transcendence through a patient investigation, a collaborative research, and an evidence-based understanding, or do we choose the safety of the premature conclusions that comfort our need for a certainty but might blind us to the genuine discoveries? A transcendence requires an intellectual courage. It demands that we fund the telescopes, train the scientists, and maintain the international cooperation that is necessary for a genuine scientific progress. It asks us to tolerate an uncertainty while remaining open to the possibilities that might challenge our current frameworks. It insists that we do the hard work of learning a spectroscopy, an orbital mechanics, and an atmospheric chemistry, rather than accepting the packaged explanations that require no effort from us. The transcendent path leads through the European Space Agency's updates, the NASA's observational bulletins, and the peer-reviewed papers that will document the 3I-ATLAS's behavior during its Mars's encounter and a post-perihelion evolution. It requires that we distinguish between an institutional analysis and a social media speculation, that we understand the difference between a scientific uncertainty and a manufactured controversy. A safety, by a contrast, offers an immediate relief from a cosmic anxiety. The alien artifact theories provide the instant explanations that eliminate the need for a genuine learning. The ancient astronaut narratives promise that someone else has already solved the problems that challenge a human civilization. The government conspiracy's claims suggest that all of the mysteries have the answers, they are just a being hidden from us. These safe explanations share a common characteristic. They demand nothing from us except a belief. We do not need to learn anything that is new to fund anything that is expensive or to collaborate with anyone who is difficult. We can remain exactly as we are while feeling that we understand the phenomena that challenge the limits of a human knowledge. But the universe seems to be designed to reward a curiosity with a discovery, an investigation with an insight, and a patience with an understanding. The successful detection and an analysis of the 3I-ATLAS represents a humanity's growing capability to observe and to comprehend the interstellar phenomena. Every measurement of its chemistry, every calculation of its trajectory, and every observation of its behavior adds to our collective understanding of how a chemistry and a physics operate on the cosmic scales. The real revelation might not come from the 3I-ATLAS itself, but from the accumulated knowledge that studying it provides. As our detection networks improve and we discover more interstellar visitors, we will develop the better frameworks for understanding the chemistry, the frequency, and the behavior of the objects from the other stellar neighborhoods. The Mars Sample Return mission, whenever it eventually occurs, could provide the definitive answers about an ancient Martian biology that would contextualize the 3I-ATLAS's arrival in the entirely new ways. If those leopard spot textures in the Jezero's mudstones prove to be the genuine biosignatures, the story of an atmospheric chemistry's delivery becomes a part of a larger narrative about a planetary habitability and a biological recovery. But even if a Mars sample return confirms an ancient life, and even if the additional interstellar visitors exhibit the similar atmospheric restoration chemistry, we must resist the temptation to impose the teleological explanations onto the natural processes. The universe might be more conducive to a life than we currently understand without necessarily a being designed for a life by an intelligence that we can recognize. The choice between a transcendence and a safety is not an abstract philosophy. It has the concrete consequences for how a human civilization develops over the coming decades and the centuries. If we choose a rigorous investigation over a comfortable speculation, we build the intellectual and the technological infrastructure that is necessary to recognize the genuinely extraordinary phenomena when we encounter them. If we choose a premature certainty over a disciplined uncertainty, we risk creating the cognitive frameworks that make us blind to the discoveries that do not fit our preconceptions. The universe might regularly present us with the phenomena that are stranger than we currently imagine, and our response to the 3I-ATLAS provides a preview of our readiness for the truly transformative encounters. As the 3I-ATLAS completes its invisible Mars's encounter and begins its post-perihelion journey back toward an interstellar space, we will have the months of the additional observations to refine our understanding of its chemistry and its behavior. The data will either confirm our natural comet's hypothesis or reveal the anomalies that challenge the conventional frameworks. Either outcome represents a success for the transcendent approach, a genuine learning that expands a human knowledge and improves our capability for investigating the cosmic mysteries. The safe approach, by contrast, would succeed only if a reality conforms to our immediate preferences and our expectations, an outcome that the universe seems to be unlikely to guarantee. What is the 3I-ATLAS doing in a Mars's orbit? Exactly what a nature does, following a gravitational mechanics, sublimating the volatiles that are based on a solar heating, and exhibiting a chemistry that is determined by the formation processes that are around a distant star. Unless we choose to see something more in the patterns that might reflect our hopes and our fears more than a cosmic reality. The final call is not to the 3I-ATLAS, but to ourselves. Will we choose the transcendent path of an evidence-based curiosity or the safe harbor of the explanations that ask nothing from us except a belief? Will we build the capability to recognize the genuine cosmic anomalies, or will we content ourselves with finding the patterns that confirm what we already think that we know? In the shadow of a Mars, an interstellar visitor continues its ancient journey, carrying a chemistry from the stellar neighborhoods that we may never visit. Whether that chemistry represents a natural coincidence, a cosmic design, or something that is beyond our current categories of an understanding, the universe waits patiently for us to develop the tools that are necessary for a genuine comprehension. The choice is ours. The consequences will echo forward into every future encounter with the mysteries that challenge our assumptions about what is possible in an infinite cosmos that seems to be equally capable of a profound meaning and a magnificent indifference to a human interpretation. Choose wisely. The stars are watching.